Learning objectives. In this chapter, the user would learn the following in detail: OSI reference model, TCP/IP model, IP addressing, classes, classless subnetting, FLSM, VLSM and supernetting, L2 fundamentals, physical layer various media like copper, fiber optic and wireless. Introduction to network fundamentals. Definition of network. A network is a group of two or more computer systems or other devices that are linked together to exchange data. Networks share resources, exchange files, and electronic communications. Uses of network. Networked computers can share files, or multiple computers on the network can share the same printer. Network architecture can be described as the structured grouping of hardware, software, and applications. The successful integration of these three elements allows for the transfer of all types of messages between users, administrators, and devices. Types of network. There are many types of computer networks. Common types of networks include the following. Local area network or LAN. The computers are geographically close together, that is, in the same building. LANs cover areas generally associated with some or all of the space within a building. In most cases, multiple workspace devices are connected to shared devices. Example, switches, servers, to form a LAN. Wide area network or WAN. The computers are further apart and are connected by telephone lines or radio waves. WANs are created by linking the networks located at two or more sites over geographic distances that extend beyond the span of a single metropolitan area. These include links between cities, countries, and, in the case of global WANs, continents. Telecommunications circuits link each building to facilities operated by a telecommunications provider, same as MANs. Metropolitan Area Network or MAN. A data network designed for a town or city. MANs are created by linking the network located at two or more sites within a city. Connections can be made using cabling or wireless technologies, with optical fiber cabling often used to link a customer's buildings to a facility operated by a telecommunications provider. Home Area Network or HAN. A network contained within a user's home that connects a person's digital devices. HANs cover areas generally associated with individual workspaces. Example, a home office or an office cubicle. Within these spaces, individual networks connecting two or more devices may be enabled using wireless technologies. A VPN or virtual private network is a method used to add security and privacy to private and public networks, like Wi-Fi hotspots and the Internet. A network that is constructed by using public wires, usually the Internet, to connect to a private network such as a company's internal network. Storage Area Network or SAN. A high-speed network of storage devices that also connects those storage devices with servers. It is a network which provides access to consolidated block-level data storage. SANs are primarily used to enhance storage devices accessible to servers so that the devices appear to the operating system as locally attached devices. Classes. Address classes. Internet protocol hierarchy contains several classes of IP addresses to be used efficiently in various situations as per the requirement of hosts per network. Broadly, The IPv4 addressing system is divided into 5 classes of IP addresses. All the 5 classes are identified by the first octet of IP address. The first octet referred here is the leftmost of all. The octets numbered as follows, depicting dotted decimal notation of IP addresses. Class A address. The first bit of the first octet is always set to 0. Thus, the first octet ranges from 1 to 127. Example: Class A addresses only include IP starting from 1.x.x.x to 126.x.x.x only. The IP range 127.x.x.x is reserved for loopback IP addresses. The default subnet mask for Class A IP address is 255.0.0.0, which implies that Class A addressing can have 126 networks, that is 2 power 7 minus 2, and 16777.214 hosts, that is 2 power 24 minus 2. Class B addresses. An IP address which belongs to Class B has the first 2 bits in the first octet set to 10. For example, Class B IP addresses range from 128.0.x.x to 191.255.x.x. The default subnet mask for Class B is 255.255.x.x. Class B has 16384, that is 2 power 14, network addresses and 65534, that is 2 power 16 minus 2, host addresses. Class C address. The first octet of Class C IP address has its first 3 bits set to 110, that is. Class C IP addresses range from 192.0.0.x to 223.255.255.x. The default subnet mask for Class C is 255.255.255.x. Class C gives 2097152, that is 2 power 21, network addresses and 254, that is 2 power 8 minus 2, host addresses. Class D addresses. Very first 4 bits of the first octet in Class D IP addresses are set to 1110, giving a range of. Class D has IP addresses range from 224.0.0.0 to 239.255.255.255. Class D is reserved for multicasting. In multicasting, data is not destined for a particular host. That is why there is no need to extract host address from the IP address, and Class D does not have any subnet mask. Class E address. This IP class is reserved for experimental purposes only, for R&D or study. IP addresses in this class ranges from 240.0.0.0 to 255.255.255.254. Like Class D, this class 2 is not equipped with any subnet mask. Classless subnetting. Subnetting. Subnets are small networks created from a bigger main network. These small subnetworks or subnets can be used for local area or LAN, virtual local area network or VLAN, or for wide area network connections as well, that is WAN, between two public routers. Subnetting is a process of breaking large network in small networks known as subnets. Subnetting extends default boundary of subnet mask. To create two networks, each will host 30 systems. Single class C IP range can be used for each. Single class C range provides 256 total addresses and we need only 30 addresses. This will waste 226 addresses. These unused addresses would make additional route advertisements, slowing down the network. With subnetting, we need single range of class C. We can configure router to take first 26 bits instead of default 24 bits as network bits. In this case, we would extend default boundary of subnet mask and borrow 2 host bits to create networks. By taking 2 bits from the host range and counting them as network bits, we can create 2 new subnets and assign hosts to them. As long as the 2 new network bits match in the address, then the address belongs to the same network. Advantage of subnetting. Subnetting breaks large networks in smaller networks, and smaller networks are easier to manage. Subnetting reduces network traffic by removing collision and broadcast traffic that overall improve performance. Subnetting allows you to apply network security policies at the interconnection between subnets. Subnetting allows you to save money by reducing requirement for IP range. Classless subnetting. A class-full network is a network that uses the same subnet everywhere, while classless use different subnets. A class-full network will only use 255 or 0 in the subnet octet, but 0 must be the last octet. So, 255.0.255.0 is not a valid subnet mask. This will allocate a set number of hosts to every subnet, and VLAN is the only way to separate broadcast domains. A classless network is basically a flexible form of the above and can use the custom subnet masks to specify subnets and number of hosts in them. In classless routing, the network boundary can be at any bit, so classless routing protocols include the subnet mask. It basically ignores the original addressing schema with A, B, and C classes to allow more efficient use of the available address space. Classless subnets, which replaces classful networks at the public space, but they allowed or kept the classful networks approach for LANs and VLANs, what is known by private networks. So classless subnets means dividing already the divided classful networks, and as mentioned, the public IP space initially was divided to 5 classes A, B, C, D, and E. And the classless approach divided these unicast classes further. Therefore, when the classless method is used at any classful network, the result is small networks known by subnets. FLSM, Fixed Length Subnet Mask, or FLSM. A fixed length subnet mask, or FLSM, is a sequence of numbers of unchanging length that streamlines packet routing within the subnets of a proprietary network. A subnet can be a geographically defined local area network, or LAN. Alternatively, a subnet may define security boundaries, departmental boundaries, multicast zones, or hardware security parameters. The FLSM is usually a string of binary digits shown over the subnet number, telling the router which parts of the subnet number to look at. A binary 1 over a particular digit in the subnet number says pay attention to this digit. A digit 0 says ignore this digit. The use of an FLSM saves a router the task of having to handle an entire IP address because the router deals only with the digits selected by the mask. Nevertheless, this method of subnet masking can result in inefficient use of IP address space because subnets are rarely filled to capacity. In networks having many unassigned IP addresses, a variable length subnet mask or VLSM can provide more efficient use of address space. IP addressing. IP address. An IP address is an address used in order to uniquely identify a device on an IP network. The address is made up of 32 binary bits, which can be divisible into a network portion and host portion with the help of a subnet mask. The 32 binary bits are broken into 4 octets. One octet equals 8 bits. Each octet is converted to decimal and separated by a period dot. For this reason, an IP address is said to be expressed in dotted decimal format. For example, 172.16.81.100. The value in each octet ranges from 0 to 255 decimal or 8 zeros to 8 ones binary. An Internet Protocol address or IP address is a numerical label assigned to each device. Open parenthesis, example, computer, printer, closed parenthesis, participating in a computer network that uses the Internet Protocol for communication. An IP address serves two principal functions: host or network interface identification and location addressing. It's a name which indicates what we seek. An address indicates where it is. A route indicates path to transmit. The designers of the Internet Protocol defined an IP address as a 32-bit number, and this system known as Internet Protocol version 4 or IPv4. However, because of the growth of the Internet and the predicted depletion of available addresses, a new version of IP, that is IPv6, using 128 bits for the address was developed in 1995. Subnet mask. Subnet mask is a 32 bits long address used to distinguish between network address and host address in IP address. Subnet mask is always used with IP address. Subnet mask has only one purpose: to identify which part of an IP address is network address and which part is host address. For example, we figure out network partition and host partition from IP address 192.168.1.10. Here we need subnet mask to get details about network address and host address. In decimal notation, subnet mask value 1 to 255 represent network address and value 0 represent host address. In binary notation, subnet mask on bit 1 represent network address while off bit 0 represent host address. In decimal notation, IP address 192.168.1.10, subnet mask 255.255.255.0. L2 fundamentals. Layer 2 is data link layer or DLL as per OSI model. As we know, function of each layer is to provide services to above layer. So DLL provide various services to layer 3, that is network layer. Various services which DLL provides are framing network layer data packets, flow control, multiple access control using carrier sense multiple access collision detection in wired network, and carrier sense multiple access collision avoidance in wireless network, physical addressing, switching, quality of service, that is QoS, virtual LANs, that is VLAN. Frames. The data link layer prepares a packet for transport across the local media by encapsulating it with a header and trailer to create the frame. Frame header contains control information such as addressing and is located at the beginning of the protocol data unit, that is PDU. The data, which is the packet from the network layer and trailer, contains control information added to the end of the PDU. Framing breaks the stream of groups with control information in the header and trailer fields. The format gives the physical signals that can be received by nodes and decoded into packets at the destination. Frames consist of following fields. Frame start and stop, that is signal the beginning and end limits of a frame. Address, that contains the address of the primary or secondary device. Type, the type of PDU contained in the frame. Quality control, to establish, configure, maintain and terminate the link. Data, the frame payload, that is the network layer packet. Error detection, to check the integrity of the frame. Flow control, data link layer protocols require control information to enable the protocols to function. The control information performs the following function. Nodes which are in communication with each other, when communication between individual nodes begins and ends. Errors occurred between the communicating nodes, the next node to communicate. Data link layer is basically divided into two sublayers. Logic link control, that is LLC, which provides services to upper layer. Media access control, that is MAC, to perform layer 2 functions like switching, physical addressing, etc. Logical link control or LLC. LLC defines the software processes that provide services to the network layer. LLC gives information in the frame that identifies which network layer protocol is being used and allows multiple layer 3 protocols such as IP and IPX to utilize the same network interface media. Media access control or MAC. MAC defines the media access processes performed by the hardware. It provides data link layer addressing and delimiting of data according to the physical signaling requirements of the medium and the type of data link layer protocols. Data link layer services and specifications are defined by multiple standards based on a variety of technologies and media. The standards may integrate both layers 1 and 2 services. Some of these standards are IEEE, ISO, ITU, and ANSI. OSI reference models. Network models. To simplify networks, everything is separated in layers and each layer handles specific tasks and is independent of all other layers. Control is passed from one layer to the next, starting at the top layer in one station and proceeding to the bottom layer over the channel to the next station and back up the hierarchy. Network models are used to define a set of network layers and how they interact. The two most widely recognized network models include the TCP/IP model and the OSI network model. OSI reference model. The objective of the OSI model is to provide a structured approach for the development of all types of network. The model specifies the sequence of processes required for network message transfer between applications running on different systems. The Open System Interconnect or OSI is an open standard for all communication systems. The OSI model defines a networking framework to implement protocols in 7 layers. Physical layer. Physical layer conveys the bit stream, electrical impulse, light or radial signal through the network at the electrical and mechanical level. It provides the hardware means of sending and receiving data on a carrier, including defining cables, cards and physical aspects. Examples include Ethernet, FDDI, B8ZS, V.35, V.24, RJ45. Data link layer. Data link layer data packets are encoded and decoded into bits. It furnishes transmission protocol knowledge and management and handles errors in the physical layer. flow control, and frame synchronization. The data link layer is divided into two sublayers, the media access control or MAC layer and the logical link control or LLC layer. Examples include PPP, FDDI, ATM, IEEE 802.5/802.2, IEEE 802.3/802.2, HDLC, frame relay. Network layer. This layer provides switching and routing techniques, creating logical paths known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing, internet working, error handling, congestion control, and packet sequencing. Examples include AppleTalk DDP, IP, IPX. Transport layer. This layer provides transparent transfer of data between end systems or hosts and is responsible for end-to-end error recovery and flow control. It ensures complete data transfer. Examples include SPX, TCP, UDP. Session layer. This layer establishes, manages, and terminates connections between applications. The session layer sets up, coordinates, and terminates conversations, exchanges, and dialogues between the applications at each end. Examples include NFS, NetBIOS names, RPC, SQL. Presentation layer. This layer provides independence from differences in data representation, example encryption, by translating from application to network format and vice versa. This layer formats and encrypts data to be sent across a network, providing freedom from compatibility problems. Examples include encryption, ASCII, EBCDIC, TIFF, GIF, PICT, JPEG, MPEG, MIDI. Application layer. This layer supports application and end-user processes. Communication partners are identified, quality of service is identified, user authentication and privacy are considered, and any constraints on data syntax are identified. Everything at this layer is application specific. This layer provides application services for file transfers, email, and other network software services. Examples include www browsers, NFS, SNMP, Telnet, HTTP, FTP. Physical layer, various media. Transmission media. The media over which the information between two computer systems is sent, called transmission media. Transmission media comes in two forms. Guided media. All communication wires or cables are guided media, such as UTP, coaxial cables, and fiber optics. In this media, the sender and receiver are directly connected and the information is sent or guided through it. Unguided media. Wireless or open air space is said to be unguided media because there is no connectivity between the sender and the receiver. Information is spread over the air and anyone, including the actual recipient, may collect the information. Copper. A twisted pair consists of two insulated copper wires arranged in a regular spiral pattern. Twisted pair, the least expensive and most widely used guided transmission medium, is twisted pair. Physical description. A wire pair acts as a single communication link. Typically, a number of these pairs are bundled together into a cable by wrapping them in a tough protected sheath. The twisting tends to decrease the crosstalk interference between adjacent pairs in a cable. Neighboring pairs in a bundle typically have somewhat different twist lengths to reduce the crosstalk interference. On long-distance links, the twist length typically varies from 5 to 15 cm. The wires in a pair have thicknesses of from 0.4 to 0.9 mm. However, It is now known that electromagnetic waves do not require a physical transmission medium and so can travel through the vacuum of free space. Regions of the insulative vacuum can become conductive for electrical conduction through the presence of free electrons, holes, or ions. Types of twisted pair: STP or shielded twisted pair. The pair is wrapped with metallic foil or braid to insulate the pair from electromagnetic interference. UTP or unshielded twisted pair. Each wire is insulated with plastic wrap, but the pair is encased in an outer covering. Rating of twisted pair. Category 3 UTP. Data rates of up to 16 Mbps are achievable. Category 5 UTP. Data rates of up to 100 Mbps are achievable. More tightly twisted than Category 3 cables. More expensive but better performance. STP. More expensive, harder to work. Twisted pair advantages: inexpensive and readily available, flexible and lightweight, easy to work and install. Twisted pair disadvantages: susceptibility to interference and noise, attenuation problem. For analog, repeaters needed every 5 to 6 kilometers. For digital, repeaters needed every 2 to 3 kilometers. Relatively low bandwidth, around 3000 Hz. Fiber optic. Fiber optic cable, a guided media. Relatively new transmission medium used by telephone companies in place of long distance trunk lines. It is used by private companies in implementing local data communications networks. It requires a light source with injection laser diode, that is ILD, or light emitting diodes, that is LED. It consists of 3 concentric sections. Fiber optic types. Multi-mode step index fiber. The reflective bulbs of the fiber move the light pulses to the receiver. Multi-mode graded index fiber. To refract the light toward the center of the fiber by variation in the density. Single mode fiber. The light is guided down the center of an extremely narrow core. Fiber optic advantages: greater capacity, that is bandwidth of up to 2 Gbps, smaller size and lighter weight, lower attenuation, immunity to environmental interference, highly secure due to tap difficulty and lack of signal radiation. Fiber optic disadvantages: expensive over short distance, requires highly skilled installers, adding additional nodes is difficult. Wireless. Wireless or unguided media transmission. Transmission and reception are achieved by means of an antenna. The direction of transmitting antenna puts out focused beam and transmitter and receiver must be aligned. It's an omnidirectional media which the signal spreads out in all directions and can be received by many antennas. Some examples of wireless media are terrestrial microwave, satellite microwave, broadcast radio, and infrared. Terrestrial microwave, used for long-distance telephone service, uses radio frequency spectrum from 2 to 40 GHz. Parabolic dish transmitter mounted high, used by common carriers as well as private networks. Requires unobstructed line of sight between source and receiver. Curvature of the earth requires stations with repeaters up to 30 miles apart. Satellite microwave application. Television distribution, long distance telephone transmission, private business networks. Radio. Radio is omnidirectional and microwave is directional. Radio is general term often used to encompass frequencies in the range 3 kHz to 300 GHz. Mobile telephony occupies several frequency bands just under 1 GHz. Infrared uses transmitters or receivers, also called as transceivers, that modulate non-coherent infrared light. Transceivers must be within line of sight of each other, that is directly or via reflection. Unlike microwaves, infrared does not penetrate walls. Supernetting. Supernetwork. A supernetwork or supernet is an Internet Protocol or IP network that is formed from the combination of two or more networks or subnets with a common classless interdomain routing, that is CIDR prefix. The new routing prefix for the combined network aggregates the prefixes of the constituent networks. Supernetting. Supernetting, also called classless interdomain routing, that is CIDR, is a way to aggregate multiple internet addresses of the same class. The original Internet Protocol or IP defines IP addresses in four major classes of address structure, class A through D. Each class allocates one portion of the 32-bit Internet address format to a network address and the remaining portion to the specific machines within the network. Using supernetting, the network address 192.168.2.0/24 and an adjacent address 192.168.3.0/24 can be merged into 192.168.2.0/23. The 23 at the end of the address says that the first 23 bits are the network part of the address, leaving the remaining 9 bits for specific host addresses. Supernetting is most often used to combine Class C network addresses and is the basis of most routing protocols currently used on the Internet. Supernetting was created as a way to solve the problem of routing tables growing beyond the ability of current software and people to manage, and to provide a solution to the exhaustion of Class B network address space. The Border Gateway Protocol or BGP, the prevailing exterior or interdomain gateway protocol, and the Open Shortest Path First or OSPF router protocol both support supernetting, but the older exterior or interdomain protocols, the Exterior Gateway Protocol or EGP, and the Routing Information Protocol or RIP do not support it. Classless interdomain is a method for allocating IP addresses and routing Internet Protocol packets. The Internet Engineering Task Force introduced CIDR in 1993 to replace the previous addressing architecture of classful network design in the Internet. Its goal was to slow the growth of routing tables on routers across the Internet. IP addresses are described as consisting of two groups of bits in the address. The most significant bits are the network address, open parenthesis, or network prefix or network block, close parenthesis, which identifies a whole network or subnet, and the least significant set forms the host identifier, which specifies a particular interface of a host on that network. This division is used as the basis of traffic routing between IP networks and for address allocation policies. Classful network designed for IPv4 sized the network address as one or more 8-bit groups, resulting in the blocks of class A, B, or C addresses. Classless interdomain routing allocates address space to Internet service providers and end users on any address bit boundary instead of on 8-bit segments. CIDR notation is a syntax for specifying IP addresses and their associated routing prefix. It appends a slash character to the address and the decimal number of leading bits of the routing prefix. Example 192.168.2.0/24 for IPv4. VLSM, Variable Length Subnet Mask, or VLSM. Variable Length Subnet Mask, or VLSM, amounts to subnetting subnets, which means that VLSM allows network engineers to divide an IP address space into a hierarchy of subnets of different sizes, making it possible to create subnets with very different host counts without wasting large numbers of addresses. A subnet mask defines the size of the subnet, that is, the number of host addresses in the subnet. Fixed length subnet masking, or FLSM, creates subnets all the same size, but where some subnets will have many hosts and some have few, FLSM results in some subnets having many orphaned addresses or some sets of hosts being too big to fit into a subnet. Where VLSM is enabled, a large subnet can be divided into a set of smaller subnets which can be used to handle smaller sets of hosts. In order to use VLSM, a network administrator must use a routing protocol that supports it, such as Routing Information Protocol version 2 or RIP v2, Open Shortest Path First or OSPF, Intermediate System to Intermediate System or ISIS, Enhanced Interior Gateway Routing Protocol or EIGRP, and Border Gateway Protocol or BGP. Conclusion. In this chapter, we have covered the following in detail: OSI reference model, TCP/IP model, IP addressing, classes, classless subnetting, FLSM, VLSM and supernetting, L2 fundamentals, physical layer various media like copper, fiber optic and wireless,